Hello everybody. Today we will talk about, as Eddie already said, about SolidProbe, the new and improved version included in SolidCAM 2013. Okay, so what we can do with the probe, SolidProbe. Until before the SolidProbe module, SolidCAM was a tool to program the machining process of the part. Today, SolidProbe helps us not only to define the machining process, it also to define the setup before the machining and to measure the part after machining. So the setup, we call it the setup, it's home definition in the machine. That means we will define homes, and after machining we can measure the part in the machine. And the third option of the SolidProbe module is tool presetter. The SolidProbe cycles generally they include a lot of options, but you will found that not all the options that we have in SolidCAM will be available on the controller. It depends on the machine controller and the available cycles included in this controller. We have one touch point in each axis. We have angle measurements, web and pocket, with or without boss, cylinder hole with and hole with cylinder. Different probe manufacturers they call it in different names. Maybe you can find it as a bore and boss, but it's the same thing. We have arcs, external and internal, measuring arcs and found the center, and also the corner, internal and external. Not only the options inside the cycle. If the cycle exists in a specific controller, maybe don't have all the options. SolidCAM takes and makes a collection of all possible options in most used controllers, and for each controller we define the options in the post-processor and what the cycle can do, and depend on this we build the post-processor. But the user interface will include all options. For this we need to define a new tool. We call it SolidProbe tool in the tool table. With the right click you can add today SolidProbe tool, and it's supported in all simulations. HostCAD, the Solid Verify machine simulation. Now let's talk about the options. The home definition. Why we need home definition with SolidProbe? Because there are different opinions and users that they use some fixtures to catch the part, and the part don't. A home definition is not needed every time you change the stock on the machine. But even in this case, when only for the first part you define the home, even in this case it's safer and faster to do it with SolidProbe, because you see what you program, you see the simulation, and you eliminate any chance of collisions in the machine. Now, even if you use a fixture to catch the part, but the home is not on a corner. It's in the middle of the stock. If the stock from part to part is vary, the dimensions vary, so this middle point, because the fixture is stable on one side, so the home will be changed from part to part. So even if you use a fixture, there are cases that you need to use the solid probe to define the home. So we recommend to use the solid probe in any case. Do it only once or do it for each part. Use the solid probe because it's faster, easier, and you eliminate any chance of collision. For those that work with castings, in machining and casting, you need datum points, so solid probe is a must. On each side, on each position of the part, you need to define a new home. So solid probe is the tool for this mission. We can do those probe measurement operations, and they will be included in the country, intermix it with other milling or turning operation, and also MCO. In Machine ID Editor, special for probe, we have a new tab, Controller Definition, and below the probe, we can define additional parameters that are specific for each controller or sometimes for each cycle. There are parameters that can appear only in, for example, cycle boss, pocket, and they will not be shown in a plain measurement. So you will define a specific parameter until each below each cycle, or if this parameter is available in all cycles, you will define it here on the first option, all cycles. Now, once you define the parameter, he will appear in the probe operation here in Technologies, Parameters. Any parameter that you define here, you will see it here, and the user can change. Most of the time you can use the default value, but if the user wants to change, just use the checkbox and change the value. We support multi-feature measurement. That means I can measure in one probe a lot of holes, pockets, change geometries that I will define in start definition. The technology allow me to define different technology, different measurement options for each technology. Yes, as I said before, the probe will be inserted, intermixed between all the operation, and we have a full synchronization. If the CAD model will be changed, because the probe can use the same geometry as the milling operation before it, for example, the contour, and when the 3D model, CAD model will be changed, the milling operation will be calculated and synchronized, and also the measurement cycle, the probe operation will be synchronized. We have full synchronization. About tool presetting, is very simple but very useful function. In the tool table, for each tool, you will define what to measure. If I want to measure this tool in the startup program, and what, length or radius. Now, for tool breakage, I can define when I want to check the tool breakage, every tool change or every operation. Now, an additional option, we have MCO. In MCO also you can define a check tool breakage in a specific position in the program between two operations. But here we define which tool will be measured in the start of program, and we already did some tests and the post-processors. We make a sub-program with all the defined tools that I want to measure. We'll create a sub-program and use it in the start of main program with a block skip. So the user can press the block skip on the machine controller, and in the start of the first part all the tools will be measured. After this he press again the block skip, so this line will be unavailable, will be skipped, and other parts will not, when we start the other parts program, this measurement will not be available. Yes, as I see here for the tool breakage. Now the differences between the controllers. We have different controllers with different cycles, but they do pretty much the same thing. They need to touch the part and to store results for each measuring point, and to find something, to find for me the center, and find the dimension of this circle. Now the behavior of a cycle vary between the controllers. For example, in Fanuc machine, the probe always will come back to the center, touch the part, back to the center, again touch the part. But for Heidenhain, from point to next point, we'll go on offsetted tool pass, offset to the geometry. So he will never reach the center point. In SolidCAM, in SolidProbe, depend on the controller that we define in machine ID, we will show a different preview. The cycle, we all the time talk about cycles. What is a cycle? A cycle is a macro program, a parametric program written by a machine manufacturer himself, or by a probe device manufacturer, because we have different controllers with built-in cycles, and we have controllers without built-in cycles. So the probe device manufacturer will already have programs, macro programs for different controllers. This program, small macro program, is doing several actions. Is moving the probe to touch the part, and he will store this position, and with this position, with this result, the cycle will do two things. He can store this value, this result, in the controller home offset table, so it's a home definition, or it's a measurement, so I can see, depend on additional parameters in this cycle, I can see it on the screen, the results, or it can be stored in a file in controller. Here we have an example of format, Renishaw cycle format. It's a call to a subprogram, 9811, and additional parameters. Heidenhain, as I say, there are controllers with built-in cycles. Before that, Siemens have built-in cycles. Haas don't have, but they work very close with Renishaw, and on each machine you will find the Inspection Plus software installed. Fanuc they don't have, but Renishaw, Bloom, Marpos, every probe manufacturer, they wrote cycles for Fanuc, and they are different for each Fanuc number series. For Renishaw and also for others, they build a few packages for the cycles. A basic cycle, a basic package, an advanced package, and there are some of them that they have also customized. They will build special cycles customized for customers. We have here an example of, yes, for basic package, all the cycles, for all probe devices, that they can measure a single point in each axis, in each plane, a 2-point, for example, a measurement of a groove, and 4-point pocket, web, arc. Now, the extended package, the advanced package, we have vector and angle measurements, printing options, and more and more. For just one example, and Renishaw has developed cycles now, more fast measurement cycles with one touch point, because most of them you will see that the probe will go to the part and touch twice to get a precise location, a better measurement value. But they develop a one-touch movement measurement cycle with the same precision. So those are advanced options, advanced packages. In the post-processor, we depend on two attributes: the cycle, probing cycles, and the machine controller. So we can build a probe with Bloom cycles, for example, on Fanuc, with Renishaw cycles on Fanuc. We have Heidenhain cycles on ITNC 513 controller. Fanuc, Renishaw have also cycles for Mazak. The Okuma, they also have built-in cycles, I know, but they are different from controller to controller. A lot of combinations that we need to take in account when we wrote the post-processor. But the important thing is that we don't need to change the post-processor, because the customer already have a working post, and to give him the support for the probe now, we are going to add only one line in post, include a file. This file will be copied to the GPP folder where all the posts are stored, and this post now, with the new include file support of the cycles, now we can generate the G-code for probe operations. At the end of this webinar, I will take a regular post, a standard post processor without probe, and we will add this include file command, and I will also tell you about a few things that you need to pay attention. Of course, as any other operation in SolidCAM, the probe, it also supports the subprograms, the subroutines. Now let's see a few examples of programming of measurement cycles in for FANUC. We have here the measurement cycles, the standard package from X, Y, and Z, single surface measurement, web, pocket, bore, boss, internal, external, corner. Now, the vector measurement cycles, we have it here. It's related to advanced package. Angle, also the web and the pocket can be measured with a rotation. 3 bore and boss measurement, 4-axis measurement in X, in Y, and more advanced cycles. Heidenheim, we have built-in cycles, so they have also the two packages. There are two options to define a home, so they call it datum, and to measure the part. So the same cycle, for example, inside the rectangle, 4 points, I will measure a pocket. Here he will define the home in the center of this pocket, and I can do also inside of rectangle a measurement. This is a different cycle, and here I will measure where is the center of this. I will get the position, the value for the center, and also length and width. Siemens, they have the same cycles but with different names, and the cycle is written in a different language, in Siemens language, but they all do the same. They can measure a hole, internal, external, a groove, a web, pocket, internal, and external. The same options almost in any other cycle, depend on the probe manufacturer. Okay, what we have more, a bloom. It's similar to FANUC. They have also single touch point, corner in 2 axes, 3 axes, inside, outside width, inside, outside diameter, angle. They all do the same thing with different cycles, different macro programs, different numbers. So the user don't need to remember all those numbers. If he wants to program this manually on the controller, he needs to know for each measurement cycle what number of the program I need to write. Yes, and what additional parameters to include. With SolidProbe, you don't need to remember this. This will be written in the post. You just use the interface, use the geometry, define the measurement cycles, and you will get the G-code. Let's start and see how simple it is to work with the probe. So first of all, let's see what we see in the PowerPoint presentation before that. Controller definition, the new tab here, and probe. We have parameter defined under all cycles. Yes, this parameter, angle tolerance, will sit in the operation. experience value, percent feedback. All these parameters are needed by FANUC cycle. Let's find in the page, I think it's 28. Yes, optional inputs. Any input that this cycle, that a FANUC cycle for any Renshaw cycle for FANUC, excuse me, needs, tolerance value, percent feedback, we will define here in machine ID editor under controller probe. So we can use them in the operation after this. Tool table. Add a new tool. You see a new tool probe, and I will define the positioning feed. I will work with 500 millimeters is enough for the probe. Now I will start to make some operations, probe operations, and let's see how simple is it. Now, I already say that the probe operations will be intermixed with machining operations, with milling, drilling, or turning if you have a turning machine, a mill turn machine. But first of all, we will use the probe to define the home. After this, we'll have the machining operations, and after machining, we will measure the part. So I need to define, first of all, the home. Home or measurement, here in start definition, we select measurement or home definition. I will use X, Y, and Z, one touch point for each axis. In X, define here touch on this surface. Select the tool. Technology. I already see the toolpath. So I'm going to give some depth, touch the part here on -20, 1, 2, 3 millimeters under this surface. I can do it with the mouse wheel very fast and the preview is updated, or I can use a peak on the surface and I get the value -20 millimeters. And
Okay, guys, I see a problem with audio, yes, and maybe with internet connection of Florin. Please wait 1 minute, we will solve the problem. Okay, guys, Florin has a problem with his laptop. It will take a few minutes. Meanwhile, I remind you, yes, this is a good time to ask all questions, yes, about the solid probe, about post-processors, yes, everything what is not clear for you, please ask now. I think this is a very good webinar because it's very well explained, yes, all the product from the beginning until the end, all the process, how to define it, how to sell it. But in any case, if you have any kind of questions, please don't hesitate to write it, yes, on the chat area. Okay, meanwhile we are taking care about for this problem, I would like to remind you that we also have a solid probe manual. Yes, and I guess you can find it on our website. If not, you for sure can find it on SolidCAM BoxNet account for resellers. So I think together with this webinar is also a good tool to go through, to understand and to clarify all the questions.
For each feature, they get the nominal value, the expected value, actual value. It's what the machine, what the probe will measure with the tolerance, and we have deviation. Now, for the feature that is out of tolerance, he will get message out of tolerance. The user needs only to, if for a part like this, he take the file and just search, find where I have out of tolerance. That's all. And he will find if any of the measured features is out of tolerance. He don't need to check dimensions for each one and to read every detail in this report. Check for out of tolerance, you will be there. And this is the way that a user can work with the solid probe faster and easier. Now let's go back to our examples. I start to define the home on this part with the probe. We talk about X. Yes, I already have the geometry. Select the tool. And as I say before, the preview helps us to define the measurement cycles very fast and easy. Mouse wheel go, I will define the level to minus 23 millimeters. The approach retract, it also work with mouse wheel. Offset, if the part have a stock allowance, maybe I have 1-2 millimeters more stock here, more material, then you can move the entire process in a positive or negative direction. Rotation angle also. We can define with the mouse wheel. You can see here also on the pictures, rotation of the measurement toolpath in both directions, positive and negative. This is used for to measure a surface like this. For example, if I want to measure a surface like this and the movement needs to be perpendicular to the surface, I need to define here an angle. But if I don't know the angle, SolidCAM will find the angle. Press on the surface, you will get the vector, and the angle is 45 degrees. You see here the toolpath is rotated. But for this surface, we don't need the angle. It's 0 degrees. On home definition, we don't need to use the parameters, but you can see the parameters here. We'll use them in a measurement cycle. Save and calculate, simulate. We have a 3D tool view today in a HostCAD. And G-code. Example of a FANUC Renishaw cycle for FANUC. Retract to the reference, change the tool, take the tool length compensation, start the device, the probe device. The device has a on-off switch to save the battery. Start the device and go with protected movement to X and Y. Go to Z clearance, to the lower level, and here we have the measurement cycle. Touch the surface and tell to the machine, to the program, here is X minus 122. This surface is minus 122. That means the home will be here in this area, in the middle of the part. I define the coordinate system in the middle of the part. Touching this surface, the value is minus 122, half of the length, 244. Save and copy. I will change to Y. Toolpath, and change the geometry. Touch this surface here. Level minus 23. So save and calculate. Now the home is defined also in Y-axis. And the geometry, I can touch the surface here on any feature, but I can also touch the surface where I have more place for the probe. I can touch it in any place on the part. I will touch this surface here, and I will say this is minus 20 millimeters, it's not 0. So the home will be defined here on the top of the part. This is the surface, minus 20. Yes, save and calculate. Let's see the G-code. Yes, you see measurement cycles. Z on this touching point is minus 20 and store to home number 1 in the tool table. That's meaning G54. Reference, switch off the probe and even send the probe device to the magazine. Don't leave it on in the spindle. Now I will take the operation, machining operation after the probe, synchronize for me, and calculate. Now I have the home defined before the machining. I will machine the part, and now after machining I will use measuring cycles. Let's start with the angle, examples of angle. Measurement. I will select a line as the geometry. The same tool. Preview, I always use the preview because it's helping me very much to see the movement. The level minus 5, 6 is enough, and I can shrink the geometry, the trim at the end and the start, because I don't want to touch the point on the edge. So I have the measurement cycle, the toolpath for this defined. Approach retract, always with the mouse wheel. and direction in the positive or negative direction. Yes. If I will select this line as the geometry, I need to change direction here. Offset is working on all probe cycles, in positive and negative direction. Save and calculate. The same geometry can be measured not only in x-axis. I can select y-axis. Now, toolpath is changed automatically in measurement in y-axis. You see how this approach retract distance helps us to position the probe between the features and not to have to avoid any collision. Yes, I will in the middle of those two features. Now X and Y, they are almost the same. Now a little bit different, the angle in Z-axis. I will select the geometry point to point. This surface is in an angle, has an angle. Select the same tool. And here on the Z-axis we can measure in the two planes, YZ and ZX. Here will be measured in a ZX plane. Preview. Now the toolpath can be shifted, and of course start and end point, move it to a better position. Clearance, save and calculate. Save and copy, and now let's define a geometry on YZ plane. Again, point to point. I don't want to draw any sketch, so I will use all SolidCAM options in geometry definition. Technology, in preview I already see the toolpath, but YZ. Again, side shift and move the start and end point. 10 millimeters. It cannot be here, the approach retracting Z-axis more than 10 millimeters, because this is the clearance that we define in home definition in Coordinate System Manager. I define the clearance on 10, but if I define it 50, 20 millimeters, I don't need to change it here. So this is the angle measurement. Web, pocket, boss pocket, and pocket with boss measurement. It can be used also as a home definition. If I want to define the home here in the center of this feature, I will measure on X and Y, and I found the center. Yes, it can be used also as a home definition cycle. But here I want to use it as a measurement after machining process. For a pocket, a boss, we need a geometry, a closed geometry chain with at least 2 parallel lines. I will use the option curve and close corners. And this line, and close with this. Thank you. the same tool. Technology, I already see the toolpath. Go up to -7, 8, it's okay because this side of the part is lower. Now, again, approach and retract help me to bring the probe to the best position between the features and avoid a collision. Offset can be used here, both sides, and measuring along x-axis or y. Now, in SolidCAM we have also the option XY, but this option is not available on all cycles on all controllers. For example, in Fanuc we have to measure a different cycle on X, different cycle on Y. They don't have a combined cycle. But Heidenheim, they have, Siemens also, they have combined cycles and measure a pocket X and Y in one cycle. But SolidCAM has the option to use the technologies. So even for a controller with not so advanced cycles, let's take here I can do only X, save and calculate. I will add a technology, and for technology number 2 I will use measuring on y-axis. Review. Now also in one operation I will use 2 technologies and measure both axes X and Y. Save and calculate. Now the same I can do now for pocket. Measure this internal. Now I don't want to define another geometry. I can define the internal geometry, yes, but it's easier for me to use the offset here. The width of the wall is 5 millimeters, so if I use here 5 millimeters offset, I can use the same geometry. Save, and for technology number 2 also in y-axis, use the offset, save and calculate. This is the pocket. For the last option, pocket with boss, I will change the geometry here to this feature. Save and copy. Pocket with boss and the geometry. Close corners. I will define internal, but you see that I can use the external with the offset. Excuse me. The tool, I already have the tool. Yes, this is the toolpath for measuring a pocket with a boss. The probe will go down, touch the part, go up to the clearance, go to the next point, down, and touch the part to avoid the collision of this feature in the middle. For X, and add technology in Y. Save and calculate. Boss, pocket, and pocket with boss. Add a new probe operation, and now we have cylinder, a hole, and hole with cylinder with boss. It's the same only that we have here additional option to define number of touch points on a circle. Measurement. Home position can be used as well. Define the geometry. To measure a circle, we need a minimum of 3 points, but depend on cycle options and the controller. You can use 4, 5, up to 10 points. Move start point. That means I can rotate this measurement cycle, this tool path. If I have some, here an obstruction, a material, something that I cannot touch the part in this point, I can rotate the entire cycle and do the measurement. The same is working as the pocket inside. We select hole, it's working inside, use the offset. And the same option also for a hole with boss. Now external and internal arc. Measurement. I will measure we can measure the radius and center of the arc. Center of arc. Tool. Always the probe. I already have the toolpath. Also, number of touch points, it's available from 3 to 10 points. I never see, until now, I didn't found any controller that support more than 4 points, but maybe for a customized cycle, a user that wanted the different cycle, and SolidCAM need option, and he will support any number of touch points. Start and end point can be trimmed by an angle. Parameters in all operations can be used. Save and calculate. The same for internal. I am working from inside. Use the offset and define the level. The probe for FANUC cycle, I am working in Renishaw Inspection Plus here with a machine. So will always come to the center. Go touch the part, come to the center, touch the part, come to the center. If you will work on Heidenheim, from this point is going on the arc toolpath offset to the geometry to each point. Save. Let's see, they want to see the G code is the same always. The movements with protected move, and here we use the advanced cycle 98823 and the 3 touch points A, B, and C. The angles of this circle. Each touch point is defined by an angle. Z level and diameter and any other additional input, tolerance, printing, print for me in a file, or show me the results, retract, pretty much the same, only the measure cycle is different. The last one that we have is corner. Let's define here this corner. The corner can be measured and also can be used as a home definition. Use this point in the corner as the home. So both options are available. Now this cycle vary from machine to machine, from controller to controller. Sometimes you can you have only two touch points, touch in A, touch X, touch in Y direction, and find for me this intersection point. And there are cycles with more than 2 points, 2 points on each side, and Y. Z level, go down. In this way, it's a more precise measurement, and it's also can found, the measurement cycle can found any angle deviation. It's working the same as internal. Okay, let's take, we already talked about all options. Yes, I didn't skip anyone. I want to take now a post-processor. First of all, let's see the example that I have here, the usage of include file. So I have a GPT file. Use this command, include Bloom on Fanuc, and the file Bloom on Fanuc include is here. In this file, in this include file, I have defined all parameters, all cycles, all options of the probe, even the probe change. It's a little bit different because for the probe I want to take the tool length compensation in at the tool change position. I change the tool automatically in this point, don't move to anywhere. In this point you activate the tool length compensation. So I use some parameters to take the value on this place. In the regular post processor, you go to clearance or to start Z value, that's 50 millimeters, and or whatever is defined in home coordinate system, and here is activated the edge length. But for the probe, I don't want to move it without a tool length compensation active. Now, probe on, I will activate the probe. So this a change tool is adapted for the probe. Now, in the main program, in the change tool, I will check if the tool type is a tool probe type, do the procedure of change probe that is included in here in include file. Yes. If not, do the regular change tool position that you define here. Let's take another other thing that we need to pay attention also. You in old posts, most of them there are the spin is activated, hard coded in change tool or even the coolant. You activate M8 in old post automatic. So here for the probe you don't have to activate the coolant. For this I have you need to put a condition if the tool type is tool probe, work with the change probe a procedure defined in the include file. Now if I'm going to take an old post, where I put it, user documentation, yes. This post is an old post from 2010. Let's see the change tool. First of all, I will use the include file. This command include copy must be between the procedures, not inside any procedure, between the procedures. I'm going to start between init post and start of file. I can insert the command include. So in this post now will be used this include find Bloom for Fanuc, for example, it will be used. And I go to change tool. So you see, as I say before, we have an M3 or M4, the tool is started, it starts spinning here, and also the coolant is activated. So if I'm looking at the example, I will put this condition, copy, before, yes, M5 and M9, the stop spin, maybe on stop coolant, okay. M1 optional stop is also okay for me, and go to the reference. Now here I put the condition, if it's tool probe, use the routine, the procedure in the include file and exit. It will not continue to do this, only if the tool is probe. So this is the only change that you need to pay attention. In change tool, most of the posts activate spin and coolant. Put the condition here and the command for include file between the procedures. That's all. And I think I cover all that I wanted to tell you. And now if you have questions, I'm ready to answer.
Okay, Florin, thank you very much for such detailed webinar. Let's see the question we have. So first question is following. Tool preset, this is for measurement length and radius inside probe, or standard for all SolidCAM option?
Okay, so the tool measurement cycles are the same as the probe, but they are not together. That means you can have a tool measurement device on the machine, and you can have not a probe. You don't have a probe, but a measuring device for tool you can have. They not use the same cycles. So you can measure the tool, and you call another cycle number. So as we see here, I don't know, maybe I have an example in you go to the next question, and I will try to find here an example of measuring, tool measuring. But the answer is they are not connected one to another. Tool measurement and probe cycles are different options. You can have both, you can have only one of them. No, it's in another manual. I don't have here the example. I didn't prepare this manual for tool measurement, but is used in the same way. A macro program, a call G65, and call a program to measure the length or radius, or length and radius together.
Okay, Florin, next question. The tool, we have several questions, but all these questions about the same, yes? Tool presetter, again,
Yes.
it's only available for customers who purchase probe, or it's open for all? Do you know?
No, this is open for all. It's not related to a probe if you, I think. I'm not sure. Now I'm not sure. I didn't.
Yes, good question, because we have several questions, guys. So
I think that is open, but I'm not 100% sure.
Okay, we will inform you. Next question. Will those include files be available for resellers?
Yes, of course. I did only 2 include files until now for Fanuc and Bloom. For Heidenhain, I built an integrated a new post machine, yes, but slowly we develop, and yes, what we have in the database will be shared with all the resellers.
Okay, Florin, and now maybe again repeat the questions, but maybe the question is too much general, but try to simplify, yes, and to answer if possible in general. Will SolidCAM provide some standard posts with the cycles to include in the posts, or do we have to write them by ourselves?
You know, as I say, if we take the Fanuc example, the Renix show, they have the inspection plus software. If the machine, you go to a machine to a customer and he have the inspection plus the cycles, you can use this file. If he has other package different than inspection plus, I don't know, there are many packages on the market today, yes, you need to write this include file to adapt to the customer's cycles that you will find to this customer. The posts depend on cycles, what the customer have. Other option, you have another option that to make a cooperation with the probe reseller, and he will give him the cycles that you already have opposed. You have Renishow cycles, okay, talk to your reseller in your area, maybe you can buy it, yes, I don't know, and give to the customer this package of cycles that you already have the post. If you cannot do this, yes, you have to write this include file or the entire post, whatever, to support customer cycles.
Hey guys, if you have more questions, let's see, this is the time to ask. In any case, I think this is very important webinar, so we will make special mass email to send you with this presentation, with recorded webinar, with everything. Okay, meanwhile, I've asked Anna these questions about if tool preset inside is default for all customers or for probe customers. Okay, the answer is, it depends on VMID definition. If it's turned on, then it will be turned on in tool table.
Yes, but the question is if it's open by the dongle.
Okay, guys, yes, we will clarify. Good question, yes, and we will clarify, and we'll answer everyone who asks this question.
If the license allow this, I'm not sure. Here is machine definition, yes, here you need to define.
Okay, we will clarify and give the professional answer 100%. Meanwhile, next question, inspection
tool
plus
measure.
package. Yes, Florin, inspection
Yes
plus
or no.
package is generally sell from probe reseller or machine customer?
Probe reseller. But it depends. I don't know. Maybe the machine reseller when he sold the machine maybe include ratio cycles and package or any other bloom or I don't know. This is their business.
Yes, but I think also it for sure sold by a solid probe reseller for sure. Yes.
For
this is
probably reseller, not solid probe.
yeah, correct. For probe reseller and for regarding the machine, I think as Florin told, if probe sold together with machine, so probably it will be there.
Yeah.
Okay, guys.
In any machine that you already have the probe, you have the cycles. You cannot buy the probe without the cycles. It comes together. But the package vary from basic, advanced, but where you have a device, you have cycles. There is no other option because you cannot use the device.
If you have more questions, this is now the last chance to answer, to ask, sorry. Okay, thank you very much. Thank you, Florin, for such a detailed webinar. It was first time done for about solid probe, so I think we have clarified many issues. And thank you for attending this webinar. And we'll see you next week again. Thank you, Florin, and all have a nice weekend.
It was my pleasure.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.
The